Hello Kickstarter folks, this is the AD8495 breakout board demonstration. Here you can see on the left, well that's my fingernail, that is the breakout board with the AD8495 mounted on it, and it's hooked up to a thermocouple here. This, for comparison, is the AD595 chip that I originally developed my reflow oven with. It's 3 times more expensive than the breakout board is going to be. But as you can see, this AD8495 part is surface mounted, so you need to have some way to plug it into a breadboard. It's plugged into this column of the breadboard. There's a connection to ground. There's a connection to plus 5 volts in this case. And then the output is going over here to this multimeter. You can read what's the output there is 75 millivolts, and it's 5 millivolts per degree Celsius, so that works out to a temperature here in the garage of 15 degrees Celsius. A little bit on the chilly side, but that probably is an accurate temperature for what actually is the conditions in here right now. It's gone up a little tiny bit. What I'm going to do is I'm going to reach over to where the thermocouple is inside of the reflow oven, and I'm actually going to put my fingers on it, and that will make it climb just a bit. As you can see there, I've influenced the temperature of the thermocouple just a little bit. Now I've brought it up to, I don't know what that math works out to be, 24 degrees Celsius, I suppose. And if I let go of it, it will go back down again. It'll take a little bit longer to go back all the way down to where it was at room temperature, but in any event, it's a very simple Kickstarter. It's just a board with a chip, 4 caps, and 3 resistors on it. But buying them in lots of 1,000 makes it possible for us to make this an even more reasonably priced thing. Plus, really, I wanted to give back because I found it difficult to find a reasonable alternative for an analog thermocouple amplifier to build my reflow oven, and I wound up buying a $15 part instead of a $4 part, simply because there was no other option. I managed to knock the thermocouple off. You can see now that what happens when you do that, when you disconnect the thermocouple, is it shoots all the way up to VCC. That is a side effect of the 1 mega ohm resistor here. The schematic of this circuit is directly from the data sheet of this part, and that way you can tell that the thermocouple has been disconnected. It works out really well because if you're using the thermocouple to control an oven, you really want the failure mode to be that the oven turns off. And if the oven is reading a impossibly high temperature, that's exactly what it's going to do. So that's a good safety thing if you're using this for a heating application. For a cooling application, it would do just the opposite, and it would try to freeze whatever you're talking about. But that's a whole different story. Anyway, I hope that this little part is useful to you in your breadboarding endeavors, and if it is, why don't you buy one? Thank you. Bye.